Whenever you're ready.
Okay, so what we did this summer is we worked in the QuarkEd part of QuarkNet. I'm Austin Irvine.
I'm Zach Harris.
And so we worked under Alice Bean in something called QuarkEd.
So Quarked is like a website for elementary schoolers and people older than elementary schoolers, and maybe even people younger than that, to play flash games so that they can learn about particle physics. And they need to get interested in particle physics so that we can group them here at KU or have them do research for the future. Yeah.
Okay, so where we started on QuarkEd, we didn't really know exactly what we were doing at all. We were very confused. We had this new programming language, we had this new program called Adobe Flash that we had to start on, and it was like, what are we doing? Yeah. And we didn't really know about particle physics either, so it was a new area. So it kind of felt like being a dog working in a chemistry lab. We had no idea what we were doing. It was pretty confusing. So how we learned. We got in the books and we got on the online tutorials.
Yeah, we also learned from just testing lines of code and using tracers and stuff, and just actually jumping right in and learning from what's happening in the code.
Yeah, comparatively it helped quite a bit. Also, we had experience with other programming languages like C++, which helped tremendously because it was similar to ActionScript programming. And I worked on the game Mass Matters, so we kind of worked separately, but I worked on this game. So pretty much you have quarks and leptons, and you have to shoot it through a Higgs field. Now every interaction tells whether this particle is more massive or less massive, pretty much. So then you have to order these particles in a mass meter down at the bottom. So you have to say, this particle is less massive, this particle is more massive. We'll show you guys later on, like the actual game. And level 2 was about density of leptons. So to escape like obstacles or get past obstacles, you have to pick different particles for density.
Alright, yeah. The next game is Tracker. And so in Tracker, the user is given either an electron or a positron with a random number of energy that's between 1 and 20. And they have to guess which detector it's going to travel through after it's launched. And so what they guess, if it's close enough to the actual movement of the particle when it lands, or when it goes through the detector, then they get points. And it teaches them about how energy affects the curvature of particles.
The bend.
Yeah, and how they curve through a magnetic field. And in the game, the magnetic field is pointing towards the page. So yeah. Level 2 doesn't exist yet. It's still being worked on, so that's something that the future people can do. There are ideas for it though, and Alice has come up with some ideas. And so what she has in mind are, you're given a series of tracks and you have to trace which one matches the number that you're given. So it's similar to the first game, only it's
a little more in depth.
Yeah. But it doesn't exist yet, so yeah.
Okay, so how we worked, for the most part we worked separately, but then every once in a while we came together, we brainstormed, we thought about different ways of how we could work out our code better, which is kind of the way how all coding works. I mean, if you need help, you have to ask someone, or it's probably not going to go anywhere. And then we set our goals every day on this really cool website called Asana, which we'll show later, which is basically for team-based projects, and it works very well.
Alright, so obviously there were a lot of problems we encountered. So
a lot. Yeah. A lot of problems. Some of these problems took us days, weeks, probably the whole time we were working with QuarkNet, and it was kind of ridiculous at some points, but I mean, it's difficult looking over someone else's coding and trying to figure out where they messed up, especially when it's not your own coding. It's very problematic. Solutions. So finding the solutions to those problems.
yeah, so again, it was hard because we didn't actually write the code, and so we had to go through it one line at a time, and go, what is this line trying to do? What does it actually do? Why are you trying to do this? And how we can fix it. And sometimes the best solution was to just scrap everything that the previous coder coded and rewrite our own code, which took quite a while.
And in a way, it kind of feels like we should have just scrapped the whole code from the very beginning, because we had like 1,000 lines of code and we had to cut it down 300 lines, and then we built it back up and then just bring it back down. It was crazy. And failure. So, like Captain Jean-Luc Picard, we experienced a lot of failure. So, the majority of the time was just trial and error for us. We would use tracers throughout the code, trying to get down and triangulate where our problem was. And then it seemed like every time was a failure, we tested the game. So we probably tested the game 1,000 times or so, and it just felt like we were never getting anywhere. But we took every defeat as a learning experience. We learned from our defeats, from our failures. And I guess at some points we almost found it kind of funny how we were messing up sometimes, and we kind of tried to find the joy in failure.
All right, even though there was a lot of failure, we did have a ton of success. And we've solved so many bugs that Alice has mentioned to us, and there's so many things that we've done, and it looks a lot cleaner. And we can definitely notice that we've learned a ton, because in the beginning, the first week, we solved like 3 problems, and it took us like the whole week to solve 3 problems. And then throughout like the next month, we were already solving like 5 problems a day and working really quickly and a lot better. So yeah.
Yep. And the progress that we made was due in part to Asana, which helped tremendously. So pretty much on Asana, I'm selling you guys this. Pretty much you like make tons and tons of tasks for yourself, and you go through those tasks, mark them down, and then eventually Asana shows you the progress that you're making. It's showing you how fast you're doing stuff, how good, and like exactly what you're doing. And it helps a lot, especially when you're working with a team, so everyone knows the jobs of each other and can build off of each other. It's really helpful.
Yeah, as you can see, there's a lot of check marks.
Yeah, so we finished a lot of stuff of bigger problems. Here's a picture of our website, and on the next slide we'll actually show you the website that we created to review our games. And Zach will play the games and explain them a little bit to you while I explain them as well. Now, when it's done loading, you're going to see some amazing website material. Like the cool symbol that I made up there for our website. And this browser does not have Flash. So,
Go ahead and open it.
Yeah,
okay.
There it is.
So the older version of Tracker is the one on the bottom, and the newest version that Zach created and developed is on the top.
Yeah, so level 2 testing.
So we go through and play. It looks a little bit different. I mean, it's hard to see from a distance, but most of the characters changed, and the whole setup changed. There's a lot of lines of code behind this that also changed. So that we have new light up things, new trails, new pathways, and overall it looks much better. The scoring system has changed. And Zach, is there anything that I'm missing? Probably quite a bit.
We added rotation. There's a lot, I don't know, there's a ton of things that's done. You
So
can check it out on your
we
own.
have the positron and electron, and the electron is naturally going to bend downwards, and in the magnetic field, while the positron will bend up. And then they have different energy levels which determine how far they actually go. So that's the tracking game. So I would say there's a lot of progress that we made on that game. Whether you think it looks like there's a lot of progress or not, there was a lot of stuff behind the scenes. This game was a real experience, I have to say myself. I spent hours upon hours working how this could. So this is the older version of Mass Matters. This is the newer version. The characters changed quite a bit. They were kind of blurry before, but I also made it randomized on the top. So if you start the game, you'll have random spots for the characters. But the biggest issue that we ran into for shooting these particles through the Higgs field was that they didn't place correctly on the bottom part. Do you want to show them that glitch really quickly? So whenever you shot more than one particle, even just one particle, it just started glitching on the question marks, and it didn't really do anything at all. But we fixed that, and fixed several other things. You guys can visit our website if you want at quarked.weebly.com, and you can see kind of some updates that we've had. You can play our games, and you can see the current issues, the new features, and what's going to change, possibly what in the future we will have in store, and what years in the future QuarkNetters will do. So I highly recommend going to quark.weebly.com to check out these games. But if you want to check out the other games as well, which some of you have probably played, you can go to www.quarked.org, and you can find all the rest of the games there.
Will these ultimately be hosted at the same site,
Yeah.
quarked.org?
Yeah,
Okay.
eventually. I mean, but first we have to finish level 2. Do you want to play through the whole game on the top to get to level 2 to show the density? It's not really finished, but you can see some of the preliminary stuff. If you guys have any questions about the game, go ahead and ask.
Have you field tested it with grade school kids?
We haven't tested this game with kids yet. Mostly older adults. Good question. Good question. Hopefully we can soon. Hopefully they can find some errors in our code and in our program that other people haven't. That would be nice. In a way. And here's kind of the lepton density game that we have. Like, we didn't really make many changes at all to this game, but just they go up and down depending on their density to avoid obstacles like that jellyfish or that anchor in the bottom.
Is there an audio component in this?
There isn't an audio component. There are some games on the Quarked website with audio, but I don't have the current skills to do that. Well, I might have some, but it would take a little bit more work.
That's it.
Yep, that's pretty much it. Thank you.